Okay, it is 5 o'clock and the bell tolls for thee. Good afternoon, everyone. Welcome to Designing Network Infrastructures for Hybrid Cloud. My name is Joe Davies. I'm a senior technical writer in the Azure Infrastructure Services writing team. I've been training, writing, and thinking about networking technologies, and more specifically Windows networking technologies, for over 20 years. Taking time out for meals, sleep, and to spend time with those people that live in my house, especially the ones that call me sweetie. What's the other term they call me? Oh yeah, daddy. I've written literally thousands of pages. Written literally, yes, it's a little writer's joke. Thousands of pages of documentation on Windows networking technologies. I was the cable guy. I wrote the cable guy column for a number of years. I've written 9 Microsoft Press books, including the most recent Understanding IPv6 version, 3rd edition, and scads of TechNet and MSDN content, some of which was actually relevant. So, I'm here to take you on a little journey. Hang on a second. They skipped my agenda slide. Okay, so I'm going to do the agenda slide completely verbally. All right, I'm here to tell you a story. And that story is, how do you think about and plan for to properly implement an Azure Virtual Network for a hybrid networking configuration? That story is going to be told in 3 parts according to classic 3-act story structure. Act 1, I call this the what and the why, gives you the building blocks, the terminology to understand the Azure networking environment and sort of relate it back to what you already know, which is you already understand the networking environment that exists in your data center. Here's how it works in Azure. Act 2 is the how, the planning and design. I'm going to take you through a number of issues of planning for Azure networking, and talk about things like addressing, routing, name resolution, and how those work in Azure and how you need to plan for them. At the end, we're going to recap in a form that gives you step-by-step procedures for doing this on your own, and a list of things that you need to determine prior to plunging into creating a virtual network with the Azure Management Portal. Act 3 is called Putting It Into Practice, and that's where we will actually take this process and this checklist and take you through the paces of setting up a fairly simple topology, a SharePoint 3-tier farm. And we're going to go through that step-by-step process. We're going to go through that checklist. We're going to actually try to configure it end-to-end. We're not going to demo all of this because it takes far too long, but we're going to show you that step-by-step process all the way through the end-to-end configuration, to give you an example. Okay? All right. So, Act 1, the setup. The what and the why building blocks. Okay, so I'm going to take you through a bunch of Azure concepts and define them, use them in a sentence. I apologize in advance if you already know this stuff. And if you do, please yawn quietly during these sections, as do not disturb your neighbor. But I'll try to get to some meat and potatoes here fairly quickly. Okay, what are we talking about? An affinity group is a way for you to tell Azure to place a set of services relatively near each other within a given data center. So optimized for performance. Call that an affinity group. A cloud service, for our purposes, is really just a container for virtual machines. Okay? It has a public presence, a public IP address. It also acts as a security boundary for allowing inbound traffic through endpoints, and you can define ACLs and so on. Okay. A storage account is just a way for Azure to account for VHDs and associated extra disks. Unfortunately, this is the only component in this list that does not have a logo. I understand that the storage account, people are aware of this, and they're frantically trying to create a logo. I think they're going to use a duck or something, so I don't know. We'll let you know how that works out. Virtual machine is just what it sounds like. It's a virtual machine in Azure. An availability set is a way for you to tell Azure, for all the servers in this particular tier of this application, this multi-tier application, I want you to place those servers on different racks in the data center so that if a given rack goes down, it doesn't bring down my entire tier. And then the last one is something called a virtual network, which we're very, very concerned with when we talk about hybrid networking with Azure. Okay, so what is this Azure Virtual Network? Well, other than it being a cute little logo with brackets and a couple of dots, it's essentially a container that allows you to structure virtual machines on subnets and with addressing that's very similar to what you would do with a data center. You can create a subnetted structure, just like your data center, and place virtual machines on those subnets and give it address space from your private address space that's an extension of your on-premises network. And we'll talk about the different types of subnets as we go along. Okay, so that's a virtual network. We have two different types of virtual networks. We have what we call the cloud-only virtual network, which has no connection back to your on-premises network. It exists completely in the cloud using reusable private address space. It has a subnetted structure, can host VMs, fine. Well, we typically use this for internet-facing types of properties where we don't want to have a connection back to our on-premises network. And we can get to them, we can project ourselves onto them with what we call a point-to-site VPN connection. What we're really concerned with hybrid networking is the cross-premises virtual network. This is so named because it is connected back to your on-premises network using either a site-to-site VPN connection or a newer type of connection that uses actual live WAN links through a provider called an express route connection. You can also use point-to-site here. The point is that once this network is in place, it is really an extension of your on-premises network. And this is a hybrid configuration, so this is the type of configuration that we're most concerned with. Okay, now with all those definitions in mind, this is a little game I like to play called the infrastructure services hierarchy to sort of give you an idea of the relationship of all these components. We have VMs that are hosted inside of a cloud service. Those can be part of an availability set. They can be on a subnet in a virtual network and be part of an affinity group. So, VMs in a cloud service, an availability set in a subnet on a virtual network, and an affinity group in the house that Jack built. So when you're configuring this, you keep this sort of structure in mind. Okay, now we're going to go through some other building blocks and describe the networking infrastructure and how everything works so that when we get to the planning and design, you'll understand how things work with respect to these blocks here. Okay, address spaces. There's something called a shared address space. This is defined in RFC 6598, and cloud providers can use this space for the machines on their backbone. Okay, so if you create a virtual machine that's just in a cloud service, you might see this 100.64/10 address. Okay, it has a 100 in front of it. The virtual network address space is the address space that I assign to the virtual network, and it's very typically, in the case of cloud configurations, part of my on-premises address space, chosen very deliberately. And then the subnet address space is derived from the virtual network address space. Now here's a very interesting one called the local network address space. This is the address space that's either summarized as all of your reachable locations on your on-premises network, or as a summary of all of your address space, whether you're using it or not, but does not include the virtual network address space. Okay, so let's look at this graphically. If here's your entire organization address space, and we're going to assume throughout this presentation that you're using the RFC 1918 address space, the 10.172.16 and 192.168. You're using that internally. Okay, there's your entire organization address space. You're going to carve out a bit of that for the virtual network. You're going to carve out parts of that virtual network to do subnets. And now the blue part here is that local network address space. So what you need to be able to do is define that local network address space relative to the virtual network address space so that it does not include it. This is more difficult than it sounds, as you will see. Okay, how do we do addressing on virtual machines? Well, there's this thing called a VIP, a virtual IP. That is the public IP address as sort of exposed by the cloud service that contains those VMs. There's the DIP, which is the direct IP. This is either from the shared address space, if it's in a cloud service, or it's going to be a private address as per the subnet address space for the subnet that it is in. Okay. And I'll leave this point about doing static dips for later. How do we map VIPs to DIPs? Well, we don't, but there is a mapping in terms of what is called an endpoint. If you define an endpoint, you're saying the public IP address of the cloud service and this port number gets mapped to this internal IP address and port number for the purposes of allowing unsolicited inbound communication to a VM in a cloud service. So looking at this graphically, we've got a couple of VMs inside of a cloud service. That cloud service exposes a public virtual IP, and those machines inside the cloud service have a DIP. And when you create this endpoint, you're essentially mapping traffic to the VIP and a port number to a DIP and a port number. Okay? All right, so how are virtual machines inside of subnets and cloud services configured? Well, they're configured using DHCP. Very long-lived leases. And some things you need to know is that there are not a lot of options being offered in the DHCP acknowledgement. There's an address with the subnet mask option. There's the router option for a default gateway. And there's the DNS servers option with a list of DNS servers that the host will configure itself for. Okay, that's really about it. Unlike your data center, you don't have a whole lot of control over creating additional options. We're used to configuring the DNS domain name, or maybe some static routes or NetBIOS settings if we're living in the 90s, or the start and ending address of the DHCP range. You don't have any control over any of that. You can't override these options, and you can't specify additional ones. However, I will say that when you configure your virtual network, you do have some control over the subnet mask, router, and DNS servers options. Those get filtered down to what the client gets configured, the VM gets configured for inside of the subnet. Okay. Now, what does DHCP configuration look like in a cloud service? If you have a VM just in a cloud service, this is an example. Remember that shared address space? Okay, here's an example of an address in that space. And basically, Azure assigns everything else. But we're more interested in VMs in a virtual network. So in a virtual network, a given VM is going to have an address from that subnet address space, corresponding to the subnet that you put it on when you created it. It's going to get a subnet mask from that subnet address space. And the default gateway is going to be the first address in that subnet address space, which corresponds to the Azure VPN gateway on that subnet. Now, the DNS servers are either going to be assigned by Azure, or they're going to be the ones that you specify in the configuration of the virtual network. Okay. Now, what about assigning a reserved or static DIP? In some cases, we want the VMs to never change their IP addresses, just like DHCP reservations, right? So the classic case is we want to put some DNS servers out in that virtual network. And when we stop them and deallocate them and start them back up again, we don't want their IP addresses to change because now the other VMs can't register its names and so on. So that's a catastrophic problem. So you have this ability to create static DIPs, to assign static DIPs, and this is all done through Windows PowerShell. Okay? So if you want to see this topic, just search on configure static DIP and you'll find the article that describes how to do this for new VMs, for existing VMs, and how to remove the configuration. All right, let's talk about routing. One of the things I was very interested in when I first started learning about Azure virtual networking and the networking infrastructure is, I'm an old routing guy from way back in Steelhead days of the routing and remote access service for Windows 2000. So how does it know, right? What are the routes on the host? What are the routes on this? What are the routes on that? How does the traffic travel? Okay. So we'll just do a quick example here where we're going to use the virtual network address space of 10.0.99/24 and a subnet address space. We're going to do the standard 3-bit subnetting of that /24 prefix for the subnet itself. Now, the first IP address in that range gets assigned to the VPN gateway. That's this little VM in the corner here by the pipe that is essentially acting as a router between the virtual network and the on-premises network. The first usable host address is 99.4. Azure uses the first 3 addresses for its own purposes. I can't tell you what the other 2 are used for. That's a trade secret. No, actually, I don't know. But anyway, it always starts with the 4th address. Okay, pretty straightforward. Okay, let's take a look at the routing. If we look at the host, the routes on the host, it's going to have a local subnet route that essentially points out all of these locations are available through this network. Okay, they're essentially on link. Okay, so we can get to all of these directly. And there's going to be a default route that points to the Azure VPN gateway, the address using the forwarding IP address of the Azure VPN gateway. Pretty straightforward. Looks like any other subnet to me, right? Pretty boring. Okay, here's where it gets interesting. If you look at the Azure VPN gateway, it has a local subnet route that points out. You can reach all the locations on the local subnet. It has a default route that points to a component called the Azure Load Balancer. And the Azure Load Balancer is this intermediate piece of software between the cloud service / virtual network and the internet. So it has a default route pointing out to the internet, essentially. And here's where the importance of the local network definition and the address spaces therein becomes very, very important, because those set of address spaces become the routes that the Azure VPN gateway uses to understand what's across the VPN connection. The local network routes is a summary of all of the destinations, the reachable destinations on your on-premises network. So if you don't get this right, what's going to happen is if you leave out a route of your local network, it's going to hit the default route and get shuttled out the internet. Nothing will result from it, because it'll probably be a private address and just get dropped at the nearest router. But this is the inherent behavior. Okay? All right. So we really need to get the local network, the address spaces of the local network correct, because that's how we can get back to the on-premises network from the virtual network. Okay, looking at the routes within your on-premises network, this is very straightforward. There's going to be a whole bunch of routes, summarized or specific, depending on their location in the backbone infrastructure, whatever, that get to all of the locations on the on-premises network, naturally. Okay, if this isn't working for you, you have other problems other than trying to figure out hybrid networking. Okay, but more importantly, for the purposes of hybrid networking, you need to have a route that points toward or points directly to that VPN device that's on the edge of your network, that's on the other side of that VPN connection. Okay? So part of setting this up is making sure you have a route back to the virtual network, just like a branch office. You wouldn't set up a branch office without a route back to the branch office. Pretty straightforward. Okay, and then of course a route on the VPN device itself that points across the VPN connection so that it gets to the locations on the Azure Virtual Network. All right, let's talk about Azure and name resolution. What do we need DNS for? Well, two things, name resolution and name registration. So we have the idealized DNS environment where everybody can resolve everybody's names no matter where they are. Okay, let's make sure we do that when we create a virtual network and we tie it back to the on-premises. So if you don't specify DNS servers, then Azure will assign one for you. And this will essentially be an internet-connected DNS server. It will be able to resolve directly names like Microsoft.com to the public IP addresses of Microsoft.com. Okay? And it'll also do name registration and local name resolution for the VMs that are inside of that virtual network. But that's not what we want. In a cross-premises virtual network, this is an extension of our intranet. We want to make sure that we're using internal intranet-based DNS servers, not internet-based ones. So we want to have these internal DNS servers, and they can be on the on-premises network or they can be on the virtual network that provide that on-premises registration and resolution capabilities and allows us to get out through the internet by resolving the name of the proxy. Okay, this is just an extension of our normal intranet types of DNS functions. Okay, now let's look at network traffic flows. Another thing that sort of fascinated me about Azure is how does the traffic flow? And we already have somewhat of an understanding of that because we know what the routes are. Okay, so there's three types of flows. There's to and from the internet, there's to and from the on-premises network, and there's between the virtual machines themselves. Let's take a look at each one of these. Internet traffic flows as initiated by an internet host. So here we have a VM inside of a cloud service. There's an endpoint that's already created so that a public VIP and port number is mapped to a DIP and port number. So, and what this allows is this user to access this virtual machine inside of this cloud service as a web server. So the traffic travels like this, okay? This is only possible if an endpoint has been defined. If you get rid of all your endpoints, then no traffic can come in, no unsolicited inbound traffic can come in to the VM, to the cloud service. Those of you who are very security conscious, you know, every endpoint is a point of attack. So you're obviously very, very interested in that, and you want to minimize that, and we'll talk about some aspects of that as we go. Okay, but in this case, we want this VM to be the web server for this service or this app service or whatever, and so we want to expose this particular endpoint so people can get to it. Okay, and of course, the response traffic is allowed because it's in response to an inbound unsolicited. Okay, as initiated by an Azure virtual machine that's inside of a cloud service, remember that it's going to send it to essentially send it to the load balancer, and the load balancer is going to send it directly out to the internet. This type of traffic flow does not require an endpoint, even though it's sort of implied here. Okay. Now, if we have a virtual machine sitting on a virtual network in a cross-premises configuration, it's going to be wanting to get to an internet site, and if that is proxyable traffic, then that's going to go across the VPN connection, through our proxy server, and to the internet in this fashion. Okay? This is typical HTTP traffic that's captured by the WPAD, and this is normal internet traffic. It's not direct, it's indirect through a proxy, and we expect our VMs to do the same. Okay. On-premises, as initiated by an Azure VM. Let's say we have a DNS server out in the virtual network. We're going to use that DNS server to do name resolution. We're going to get an IP address. We're going to dump that request off to our VPN gateway. The VPN gateway is going to look in its routing table. The local network routes are going to match, and it's going to send it across the VPN connection. Pretty straightforward. Similarly, for initiated by an on-premises computer, they're going to use their local DNS server to resolve the name, and they're going to send it across using that route that points to the VPN device. They're going to send it across the VPN connection in this way. Again, very, very straightforward. Traffic between VMs really just occurs directly. Okay, there's some sort of magical layer 3 switching going on there. I can't really discuss it. I don't really know what it is, so I really can't discuss it. But just know that there's not virtual routers between these subnets. It's really going direct. So nothing to worry about there. Now, what about traffic between VMs in different cloud services or different virtual networks? Here we have a cloud-only virtual network, and we want to get to another cloud service, another VM and another cloud service. Okay, we're going to do that. The virtual machine is going to go through its load balancer and go out to the internet, and hopefully there's an endpoint defined in the cloud service on the left that allows that traffic in. So that's going to look like this. Okay, so we're going direct over the internet in this particular case. However, for a cross-premises virtual network, we're going to go over the VPN connection, through the proxy server, and through the cloud service endpoint in much the same way as we would do in any sort of internet connectivity. Okay? All right. That is the end of Act 1. Now, with all of that information resident in memory, let's get into the planning and design of what do I need to think about? What are the key decisions that I need to make in order to properly plan a virtual network for Azure so that when I get to the wizard, I know exactly what I'm doing. Okay. What are the primary configuration scenarios for hybrid cloud? Well, I call this the internet facing with on-premises administration. So we're exposing some sort of website to the internet, so consider it sort of an extranet sort of replacement. I've defined endpoints that allow that unsolicited inbound traffic into those websites. So that's that kind of traffic. But I'm actually administering this server farm or whatever, this web server farm, over the VPN connection itself. Okay, so doing remote desktop, remote PowerShell, et cetera, over that connection. All right, so internet-facing, on-prem, it's an extension of my on-prem network, but I'm just allowing some endpoints to get to those services and administering on the back end. Okay. The other one is called the on-premises only, and this really is an extension of your data center. How many people have data centers with direct internet access? Okay, all right. So private data centers with direct internet access. I was being a little facetious there. In some cases, your data centers have no direct internet access. You don't want them to. It's private data, and this is sort of an extension of that, where it's a cross-premises virtual network, of course. You're extending this data, and you're doing everything over that VPN pipe. So here's a security tip, is when you create a virtual machine using the wizard, by default, it creates an endpoint for remote desktop and remote Windows PowerShell administration capabilities. And those endpoints are for coming in over the internet using either remote PowerShell, or you can go through the management portal and it'll create an RDP file for you. Well, if you're doing everything over that VPN connection, you no longer need those endpoints. So you can actually get rid of those, and nobody can try to get into your servers using remote desktop connections in that way, because they have knowledge that that's the default as well. Now, I know what you're saying. Well, okay, this is a single VPN connection. What happens if it goes down? It used to be that you could only have a single VPN connection to your virtual network. They just announced this week, and there's presentations at TechEd this week that talk about how now virtual networks can have multiple connections. We can have a fault-tolerant connection back to CorpNet. So this, I show a single connection in almost all my drawings, but know that there can be multiple connections. And you can actually connect virtual networks to each other as well for fault tolerance. Okay, so that's the on-premises. One of the things you're going to have to figure out along the way is exactly how many virtual networks do I need? Think of a virtual network as an island of compute resources. It's the existentialist view of virtual networking. Each virtual network is an island. Every one of these can be a separate data center with a bunch of servers with a defined purpose, for example. A web farm, a SharePoint farm, a disaster recovery site, a site for seasonal or regional workload scale-up, etc. And I mentioned the talk about multiple connections here. Okay, so one of your key design decisions is how many do you need, one or multiple virtual networks to serve your needs? And you have to go through this, and if there are multiple, then you really need to do this planning process that I'll describe a little bit later for each one of those to make sure you get all of the variables and parameters right. Okay, so within the virtual network, what set of VMs within, what sort of purpose it's going to set. And luckily, there's a common set of local networks and DNS servers that apply to all virtual networks across a subscription. So if you define a DNS server, for example, that's available to all of your virtual networks that you create or maintain. So we're trying to make the administration a little bit easier. Okay, let's talk about the design considerations around name resolution within the virtual network. Azure's going to assign a DNS server to those VMs. You can have, if you don't specify that, then Azure's going to give those VMs its own DNS servers, but that's not recommended. We want private DNS servers for our intranet. Fair enough. Okay, so another interesting behavior around Azure is it doesn't support any broadcast or multicast traffic. So if you're used to resolving computer names through NetBIOS broadcasts, and there's another mechanism that's multicast-based called Link Local Multicast Name Resolution, or LLMNR. It's also a tongue twister. Those don't work in Azure. The only name resolution that works is unicast DNS queries and responses for fully qualified domain names. Okay, so let's think about that, and we'll have some effects later on. So the big decision here is, where do you want to place your DNS servers? Do you just want to have them on the on-premises network, or do you want to actually place DNS servers in your virtual network? When does it make sense to do so? All right, let's take a look at that. If DNS servers are on your on-premises network, then that's good, right? Because you don't have any additional DNS servers to manage. There's forwarding behavior that you have to configure and make sure that it's working. And with a new DNS server in a given zone, an existing zone, you have to do DNS zone replication and who's the master and who's the secondary and all that other stuff. Okay. The downside is when you have it in this configuration, all of the DNS traffic, name registration and name resolution, goes over that, goes over that connection. Two VMs in the same subnet of a virtual network, if they try to resolve their names, it's not going to be a multicast. It's going to be a traffic over that of the VPN connection to the on-premises DNS servers. The outbound traffic adds to your ongoing costs. If that's important to you, does it make sense to have a DNS server in the on-premises network versus the virtual network? Okay. Now, if we have the DNS server in the virtual network, then all that name registration and resolution that's local to the virtual network stays on that side, doesn't go across the pipe. Okay? But the downside is I've got new DNS servers, so I need to configure forwarders. I need to configure the appropriate zone replication. So once again, I get the DNS nirvana that everybody can resolve everybody else's name. So here's the DNS traffic. We do the local name registration this way, and we do either forwarded DNS queries, and the zone replication traffic happens over the VPN connection. Okay. Let's talk about IP address management. This is where it gets very interesting. Again, Azure assigns an IP address and subnet mask through DHCP. Pretty straightforward. Here's the Azure limitation. We don't support what I call route summarization or address summarization when it comes to defining the virtual network address space and the local network address space. So one of our decisions is, what is the virtual address space? What is the private address? We have to do a private address space for the virtual network. We won't allow anything else. So what is that address space? From what bank of private addresses does it derive from? We need to make it large enough so that it can accommodate all of our subnets and all of the machines that we might have on those subnets. But it has an implication that we need to now define the local network address space in terms of the whole created by the virtual network address space. Okay. Blank stares. Let's talk about this a little bit more. Route summarization, true route summarization, allows what I call overlapping addresses. I can have the 10./8 and the 10.0.100/24 both existing as routes in a routing table. Those are overlapping addresses, right? Because the 10./8 assumes the 10.0.100. But with the closest matching route algorithm that routers use, it has no problem with this. For destinations on the 100.x subnet, it'll use that route. Anything else with the 10 in front of it, it'll use the other route. However, Azure does not allow this overlapping behavior with respect to virtual network address space and the corresponding local network. So I can't have 10./8 for the local network and 10.0.100 for the virtual network. I must explicitly define the local network address space so that it does not include the virtual network address space. Okay. So how do I define this local network address space? You can include both private and public address spaces, so the traditional private address spaces of 10.172, et cetera. And you can also use IANA-allocated public address space if that corresponds to reachable locations on your on-premises network. Fine. Two different ways to define the local network address space. Number one is the set of prefixes, not including the virtual network address space, that are currently in use. So you've used this bunch of 10 dot and used this bunch of 172.16 and this bunch of 192.168. And that's going to be your local network address space. Fine. But when you use a new 10 dot prefix or a new other prefix, you're going to have to go back to the local network address space and know to add that. It's a little bit of an administrative headache. Option two is to define the local network address space relative to the virtual network address space for your entire on-premises address space, regardless of whether it's being used. That way you don't have to keep going back when you add new subnets and routes and so on. You will have to modify it if you, for example, use another public address space on your intranet. But that's a relative rarity. Who has public address space anymore, right? Okay, so the big decision here is how do you define that local network address space? Because that's going to define the traffic that the VPN gateway sends across the VPN connection. All right, here's where it gets really interesting. Okay, a step-by-step process for figuring this out. Number one, define the initial local network address space in terms of those address spaces that the virtual network address space is not derived from. And then you want to define the set of prefixes around the whole corresponding to the address space from which the virtual network address space is derived. I call that the root space. Now, depending on if it's 10 dot or 172 or 192, 168, you may have multiple octets of complexity. Remember your subnetting? Anybody? Okay. You may have to define the non-overlapping prefixes in a previous octet, and then the non-overlapping prefixes within the octet as defined by the virtual network address space. Yikes. Was that really a sentence? Yes, it was. Here's what it looks like visually. Let's say this is the entire address space for 10 dot or 172.16 or 192.168. And here's the whole created by the virtual network address space of an arbitrary prefix length. Well, you're going to have to subdivide that address space, maybe along octets, and you might get this sort of designation. And then within that rectangular bar that includes the virtual network subnet again, and the local network address space then is all of the blue rectangular bars and the blue squares. That's your local network address space relative to the virtual network address space that creates the whole in the larger address space as defined by the private prefix. Yikes. Question? So the question is, what is the smallest possible address space so you can optimize and minimize the number of local. I haven't quite figured that out yet. That's a great problem to noodle on for later. Okay, so let's go through an example. This is almost the worst case scenario. Okay, there is a worst scenario that I won't even get into, but just to give you a flavor for how this works in a multiple octet situation. I don't want to make you run screaming for the doors, but I just want to give you a heads up that this is a non-trivial exercise in figuring out what's the right local network address space. Okay. We're going to be, this particular organization is using all three addresses out of all three private address spaces, and they're using a 131.107/16 on their on-premises network. Fine. They have chosen the virtual network address space of 10.0.100/24. Yikes, because that's in the 10 space that has multiple octets. The hairs on your back of your neck should start standing up, as they are with mine. Okay, so we call the virtual network root space is the 10.0/8. Step one of this enumeration process is to define the address space that does not include the virtual network root space, that doesn't include the 10 dot. And this is very straightforward. It's just these three address spaces. Okay, so that's sort of the initial set of local network address spaces. It gets more interesting. Now let's define the non-overlapping prefixes for previous octets, skipping the prefix that includes the virtual network address space. And what we're essentially looking at, it doesn't line up too well, but we're essentially looking at this second octet. We need to define the address space in the second octet in such a way that it excludes the virtual network address space. So what we do is we enumerate all of the /16s, skipping the one that includes the virtual network address space for a total of, hold on, clicker problems, 255 possible prefixes. So now I have 255 prefixes that are part of the local network address space that I need to enter in for my virtual network configuration. Okay, now let's go to the octet, the third octet, and see what trouble we can get into there. So, but visually, this is what happens. we took the 10.0/8 space, we subdivided it along the 16-bit boundaries, defined 255 prefixes, skipping the first one that contains the virtual network address space. Okay? All right. Now let's dive into that first network, that 10.0.0/16, and see what sort of trouble we can get into. Step 3, within the octet that contains the virtual network address space, enumerate the non-overlapping prefixes, skipping over the virtual network address space. So we're looking at this third octet now. Incorrectly aligned, I'm sorry. So we enumerate those, starting with 10.0.0/24, enumerate them. We skip over the 10.0.100/24 for a total of 255 prefixes. So here's what it looks like graphically. We're taking this 10.0/16, we're subdividing along the third octet, we're starting to enumerate them, we skip over the 10.0.100 for, again, a total of 255 prefixes. Now, we're ready to compile the list of prefixes. We have the first 3 that were not part of the root space. We have 255 for the /16 space. And we have another 255 for the /24 space. This is the definition of the local network address space for this corresponding virtual network address space to work around the whole. So again, I took this as a almost worst case. It's almost the worst case scenario, because the worst case scenario would be subnetting within the 4th octet of the 10 dot space. You'd have even more, right? Crazy go nuts. Okay. This assumes that you're using portions of the private, all 3 bits of private address space. If you're not using 192.168, then you can use that for your virtual networks, and you only have 2 network prefixes to put in your local network address space. But the assumption here is that you're using some of the 10, some of the 172, and some of the 198, and therefore you have to, be very careful about defining that, again, around the whole that's created by the virtual network address space. Who wants to put 513 address prefixes into the Azure Management Portal? I don't. So here's a tip. Step 1, put in the non-root spaces, the first 3 using the portal, and we have an export to XML import back in, where you can add the rest of those, the 510, in a text file format. And I'll demo that here in a little while. Okay? So, defining the virtual network address space is a non-trivial exercise. I'm here to tell you, give you a heads up on that. Okay, let's talk about virtual networks and subnets. How do I define the subnets within the virtual network? Well, how do you define the subnets within a normal data center, a normal bank of addresses? You create those boundaries however you normally create them, sometimes along security boundaries to define ACLs based on prefixes rather than individual IP addresses. Whatever subnetting process works for you in your data center will work here as well. Okay. Azure endpoints are defined on a per IP address, per DIP basis, per VM basis, not by subnet. But you can also define Azure ACLs to allow inbound traffic based on subnets. So that's one reason that people do subnets in Azure Virtual Networks. There's this other thing called the gateway subnet, which provides the fault-tolerant routing across the VPN connection. So we have to create that when we create the virtual network. Okay, some interesting behaviors and limitations. By default, the management portal will do a 3-bit subnetting of whatever virtual network address space that you put in there. Okay, so up to 8 subnets. You can override this, of course. And here's the other thing that I mentioned before. Azure's going to use the first 3 addresses. So what's the formula for figuring the maximum number of IP addresses per subnet? It is now 2 to the n minus 5 instead of 2 to the n minus 2, because Azure uses an additional 3. Okay, so the question here, the design decision is, what is the set of subnets and their purpose that is based on the virtual network address space? Another element is scalability. Do I scale up or do I scale out? There's two ways to do this. Scaling out is I'm going to add smaller VMs to scale out very quickly, as opposed to big honking VMs that sit there idle. Because even if I create a big honking VM, I'm still using storage space. So the recommendation is to scale out using additional VMs rather than scale up using a smaller number of very, very large VMs. So you're not having them sit idle and incurring those costs. So that has an impact in your virtual network. Do you have enough address space within that virtual network on the subnets to do an appropriate scale out as opposed to being forced to scale up? Okay, so building your scale out capacity into your virtual network and subnet address spaces. That's a decision you're going to have to ponder. What's the maximum number of machines I might have on this subnet, and subnet appropriately? Okay, let's recap since we talked about a whole bunch of stuff here. What is your virtual network address space? And what is the corresponding local network address space? How many subnets, and what is the address space for each? You have subnets for virtual machines, and Azure's going to carve out 8 addresses from one of your subnets to do the gateway subnet. How do you define that local network address space? Are you going to define it in terms of just the reachable addresses that you have to maintain, or your entire address space that you don't have to maintain, working around that hole that's created by the virtual network address space? And are you going to reuse reserved IP addresses for static dips? Okay, so from the routing perspective, we want to be able to route from the virtual network to the on-premises network. That is facilitated by the local network address prefixes. From the on-premises to the virtual network, we need to advertise the route corresponding to the virtual network address space from that VPN device, make sure that that's reachable from our on-premises network. So the decision here is, how does that route get advertised into your routing infrastructure on your on-premises network so that that traffic finds its way to your VPN device? Another decision around routing is, what VPN device are you actually going to use? Is that static or dynamic? There's a designation there. A static is sort of a policy-based router, and dynamic is more a routing table-based router. Look for the topic called About VPN Devices for Virtual Network for information. We have templates available to configure a set of devices that are already out there. Now, computer management infrastructure is actually pretty straightforward. The virtual machines and the virtual network are part of your intranet. They're directly name resolvable, they're reachable, they're part of the appropriate ADDS domain. Okay, you just add them like you would any other machine using your ad management infrastructure. You may make allowances for the fact that it's a lower bandwidth connection out to that particular location, but treat them similar to branch office computers in that respect. So, how do you add your Azure computers to your computer management infrastructure? Through Active Directory. I'm not a System Center expert, so I couldn't tell you how to do that, but you just do that in the normal way. Okay, last but not least, load balancing. From the internet to the VMs, Azure, from a long time ago, has this ability to do a random distribution, random load balancing, from a load balance set from an endpoint to a set of VMs inside of a cloud service. Okay, we call this just Azure load balancing. So here's two web servers and a web server farm, and Azure's just going to randomly distribute those between those two. Okay, from your on-premises network to the VMs that are in the on-premises, the cross-premises virtual network, what you used to have to do is set up a load balancer either on your on-premises network or as a VM inside of Azure, the Azure Virtual Network, adding additional costs. So the traffic would hit the load balancer and it would distribute it to the two web servers in this case. But this week we announced something called Azure Internal Load Balancing. I just wrote the docs on this, and it just got published on Monday, where Azure now will provide this service for you. You can set up an internal Azure load balancing set and essentially take the place of that extra device that you had to put up in your in your on-premises network or your virtual network. Okay, so now traffic can be load balanced by Azure when it hits the Azure Virtual Network. Azure internal load balancing can also be used to distribute incoming traffic between a front-end server and a back-end server. So figure a front-end is a web server, back-end is a database server. It can now do that sort of internal load balancing as well. So the question becomes, what load balancing do you need, and how do you need to implement it? Is it between application tiers, or is it between clients and servers, the clients being external to, on the internet, or the clients being on-premises network clients? Okay, let's recap in a couple of different ways. The first way is, what is the step-by-step process that you need to go through to figure out how to do a hybrid cloud implementation with Azure Virtual Networks? Number one, what virtual networks do you need and what are their purpose? Number two, what's the DNS configuration? How are you going to handle name registration and resolution so that you get DNS nirvana? Everybody can resolve everybody's names to their addresses. What's the address space for the virtual network and its subnets, and therefore the local network address space? What's the IP routing on your on-premises network so that it knows that that address space is available across the VPN connection? And what sort of load balancing requirements do you need? Okay? Now, let's recap in another way, which is what you need to know to configure the Azure Virtual Network in the management portal. There are a bunch of names and settings. There's a name to assign to the Azure Virtual Network. So consider this sort of a checklist. I need to write all this stuff down before I plunge into the wizard. Okay. A name to assign to that local network that you're going to define, that set of address spaces across the virtual private network connection. An Azure affinity group is required for a virtual network. What is the public IP address of your VPN device on the internet? What is the set of DNS servers that you're going to assign to the VMs in the virtual network? Okay, there's more. Addresses and address spaces. What's the virtual network address space? Typically a single prefix. This could be multiple prefixes as well. What's that local network set of those prefixes that doesn't include the network address space, the virtual network address space? And for each subnet, what's a friendly name for that subnet and its corresponding address space based on the overall virtual network address space? And what set of addresses are you going to reserve for static dips, for say DNS servers? Now, even after you've run the wizard with all of that information, you've collected all that information, you've run the wizard, you've created the virtual network, you're not quite done. What you need to do is actually complete the configuration to get that site-to-site VPN connection up and running. So in Azure, you're going to go back into that virtual network and you're going to create a gateway, either static or dynamic. And then you're going to go to your VPN device, tell it the public IPv4 address of the Azure VPN gateway, and configure it with the IPsec pre-shared key for the IPsec tunnel between the two endpoints. And you can get to that through the portal and the path described here. Once that site-to-site connection is up and running, then you can start hosting VMs. You can do one or more cloud services to contain the virtual machines. You can create an iconless storage account to hold the VHDs and the extra disks. And now you're ready to start creating or migrating actual VMs out into the virtual network. So again, a non-trivial task, I grant you, but a way of extending your network out into the cloud without the hassles of creating another server, creating VMs within, and so on, getting yourself out into that environment. Okay. Act 3. How do we put this into practice in a relatively simple, straightforward way for a sort of a common configuration? Okay. We're going to create a virtual network, a cross-premises hybrid configuration that hosts a SharePoint 3-tier farm. It's an on-premises only farm. It's an on-premises only virtual network, cross-premises only. It's an on-premises only cross-premises virtual network. That's not a noun stack. I don't know what it is. We're just going to do a minimal configuration. We're going to create this SharePoint 3-tier farm to do archiving. We're going to set up the farm, and then we're going to start moving old documents to it because our current SharePoint farm is just littered with gobs of God knows what. So we're going to start moving stuff out there. And just get things started, we're going to have 2 servers in each server role. Okay, let's go through our step-by-step process. How many virtual networks do I need? Well, I just need the 1. Okay? And I'm going to use that to host the VMs of this farm. And the farm has a 3-tier design corresponding to web servers, app servers, and database servers. Okay, pretty straightforward. Step 2 is figuring out the name resolution, the DNS configuration. Now, this SharePoint farm is going to be using Windows Claims authentication to authenticate users that are trying to access it. So rather than have all that AD authentication traffic traveling over the VPN connection, we're actually going to set up a couple of domain controllers in the virtual network so they can do local SharePoint authentication. Of course, those domain controllers are going to be DNS servers so that we can do local name registration. We're going to do DNS forwarding to the DNS servers on the on-premises network. And we're going to do DNS zone replication, so again, once everybody can resolve everybody else's addresses. That's step 2. Step 3 is determine the address spaces. So we're going to use 192.168.100. I can't seem to get away from this 100 for the virtual network address examples. Next time I'll do 101 or something radically different. And then we're going to use the standard 3-bit subnetting for the subnet, a single subnet within to house, again, this very simple configuration. Okay. What's our step 4? Determine the IP routing. We're going to make sure that that VPN device is advertising a route out to the rest of our routing infrastructure corresponding to the address, the virtual network address space. Okay, so everybody knows how to get to the virtual network. Okay, step 5 is determining the load balancing requirements. Now, this is not an internet. This is premises. This is on premises only. So there's no endpoints, but we do want to provide internal load balancing. So we're going to set up an internal load balance set to be able to spread the load coming from the on-premises network to the different front-end web servers. So we're going to set up an ILB configuration. All right, that's the 5-step process. Remember, we have a checklist of things we need to figure out. We're going to call the virtual network SP FarmNet. We're going to create a local network called CorpNet. We're going to create an affinity group called USA Group. We're going to give it this public IPv4 address. And we're going to assign it these 2 on-premises network DNS servers initially. Okay, and in terms of address spaces, we're going to we've defined this virtual network address space. The local network address space consists of the 10 network, the 10 space, the 172.16 space, and the 255 prefixes around the virtual network address space in the 192.168 space. Okay, so a total of 257 prefixes for our local network address configuration. We're going to do one subnet for now, SP Farm subnet. We're going to give it this default address prefix. And we're going to set it up so that the first 2 VMs are going to be our domain controllers and DNS servers using the first the first 2 addresses in this particular subnet. And we're going to reserve those as static dips because they're going to be DNS servers. And the set of eventual DNS servers are going to be reconfigured later on to use these 2 IP addresses. But we're going to use the on-premises network DNS servers for now because we need to get the domain controllers up and running. Okay, let's recap very quickly. There's the addresses of our DNS servers, our IP address of our VPN device, virtual network address space, subnet address space, and the 2 DIPs. Now, when we create and configure the SP FarmNet, the name of the virtual network, we're going to create it in the Azure Management Portal. We're going to do a custom create. We're going to use these 2 on-premises DNS servers. We're going to add the first 2 prefixes to this local network named CorpNet. And then we're going to add the remaining prefixes, checking my time here, by doing the export-import function. Okay? So let me demo that for you now. So I'll be... Hopefully this will work. And of course it does not. Okay. Okay. I'm going to go ahead and call it. We're running a little bit late on time. I do want to have some time for Q&A. So let me go ahead and breeze through the rest of the information real quickly. I'd be happy to talk with you about the demo that didn't work a little bit later on. Okay. Sorry about that. Okay, so assume the demo worked in your mind. All right. We're still not quite done. Okay, we've got this virtual network with all the things that you just remembered from what I said 2 minutes ago. We're still not done. We need to set up that routing infrastructure so that so the VPN device is advertising that route out. Okay, that's fine. The next thing we need to do is set up that VPN connection. So we create a gateway within that virtual network inside the management portal. We configure the IPsec settings for the VPN device, and we get the site-to-site VPN connection up and running. Okay. Now, we're going to create that first VM. It's going to be a domain controller, so we create that first VM and add a data disk because a domain controller out in Azure needs to have a separate disk. I won't bother you with the details. Once that VM is up and running, test connectivity by pinging a location on the on-premises network, and then use NSLOOKUP to look up a name that you know on your on-premises network. Do we have connectivity? Do we have name resolution? If we do, we go ahead and complete the DNS configuration. We create that second VM, add a data disk because it's going to be a domain controller. And we configure these two first VMs to use these static dips. They're going to become our DNS servers on this virtual network. We join them to the domain, and they can find the domain. Why? Because they're being configured with the DNS servers of the on-premises network. We make them domain controllers, so now they are DNS servers unto themselves. Then we reconfigure the SP-Farm virtual network to now use these two addresses as their DNS servers. So as we add the SharePoint servers and so on, those SharePoint servers and SQL servers are going to inherit these two IP addresses as DNS servers rather than the on-premises ones. And that's proper because that's what we want in our virtual network. We want local DNS servers. Okay, and then we configure these two DNS servers to do the appropriate zone replication. Now what's interesting is that they were configured with the on-premises DNS servers. When you make them domain controllers and make them DNS servers, they automatically add those DNS servers as forwarders. So they're all automatically configured as forwarders. You just need to add the additional configuration so that they become zone replicators as well. Okay, so any new machines that are going to be populated in that virtual network are going to use these two IP addresses as DNS servers and register themselves, and then those names are going to get replicated over to the on-premises network. Okay. Now we create the additional VMs in the farm. Remember, we just got the two domain controllers. So we're going to build out the two layers of web front end and application servers for SharePoint, and we're going to build out the two SQL Server machines. And we can use the trial images and the SQL Server images very easily. We go ahead and set up the SharePoint farm to use those SQL servers, the two tiers. But remember, we want to do some internal load balancing across the web front ends. So we're going to add an internal load balancing set so that the incoming traffic from clients on the on-premises network get distributed across those two front end servers. When you create an internal load balancing set, it's going to use one of those virtual IP addresses on that subnet. And that is the IP address that we want our clients to send their requests to. So on the on-premises network, we create DNS entries that map the farm name to that new internal load balance set VIP. And now all of the requests to that name get forwarded to the internal load balancer, which again distributes them across the two front-end web servers. And that's it. It is really just that easy. I'm being facetious. This is a little bit of an exercise, I grant you, but now you've got a functioning SharePoint 3-tier farm out in your Azure Virtual Network. Some of these steps can be compressed. For example, you can when you create the VMs, you can add the dips to them during the VM creation, so you can save a step there, obviously. But some of these machinations are just because what we want to do is we want to be able to find the domain controllers so that the two new domain controllers can join the domain and so on. So we do a little bit of manipulation there to facilitate that. But beyond that, it really is a matter of a sort of a staged deployment of this particular farm. Okay, real quickly, I'll go through the resources. There was a hybrid cloud strategy session that was earlier today. If you were to catch that, there's extending your premises with virtual networks and ExpressRoute. That's on Thursday. That talks about some of the new virtual networking features, and ExpressRoute, which is that WAN-based connection to Azure. There's some labs. I'm personally working at the CSI booth in the data center and infrastructure section of the expo. And I'm also running an effort called the Solutions Advisory Board, where we get together with customers and we discuss solutions, which are combinations of products that can be used to solve particular business problems. And we're getting into the solutions content business rather than just the product feature siloed business. So if you have any interest in that, please come see me at the Ask the Experts table in about half hour or so. And we also have a dedicated SAB session where we'll be presenting our latest efforts in the solution space in the Hilton Americas room 335A, which is just across the walkway, and the third floor, tomorrow from 4 to 5:30, if you have some interest in that. Okay, that's pretty much it. Let me just get to please complete an evaluation. And here's the way to get that. I'd like to open it up for Q&A. We have about 8 minutes. Apologize for going a little bit long. I'd like to invite my team member, Cheryl McGuire, who wrote the virtual networking documentation, to help me answer any questions you might have. So if you have questions, please go to the mics so that the entire room can hear them. So any questions you might have about figuring this out, planning and deployment, and the end-to-end configuration? Yes, sir.
A question about internet traffic from virtual network to the internet in case of cross-premise configuration. The traffic from virtual machine in the virtual network to the internet go directly from Azure, or is possible to constrain also internet traffic, not only HTTP, through cross-premise network?
Okay. So I think your question is it possible to prevent traffic from the virtual network going directly to the internet?
Yeah.
In the case of a ping of a public IP address?
Yeah.
I don't think that there is at this time, but
yeah.
it is something that the product teams are aware of, as far as I know.
Yeah.
Okay, so virtual machine in the virtual network have internet access.
Right, if you're initiating the traffic from the virtual machine, it's going to go out, yes.
You can still use group policy and push a firewall config on, right?
I'm sorry, what was that comment?
You can still put, you could, if it was group policy, if it was AD join, you can push a group policy and push firewall config on to constrict that device.
You could block, right, in that way, but we can't do it through the networks itself.
Yeah, not on the
we can't
network,
do
but I'm saying off the host you
can
can do it.
Yeah.
Right.
If you want to control that.
Okay, and just a curiosity about the PV6. You talk about only PV4, but there is no
there's no IPv6 support at all at this time.
Okay.
I wish there was. I'd have a lot more to talk about. Okay, question, Ed?
So recommendation, AD sites and services, sites and subnets. Would you set up your Azure site component within AD sites and services, put that subnet in there, just like you do branch, office location, everything else, right?
Yeah,
For replication.
you'd have to, I'm not sure how you would determine the relative bandwidth and throughput.
Right, that's what was going to be my next
But yeah,
question.
you would do a similar treatment to say that this is across a slower link, so that AD can do the right thing when it allocates its addresses.
Okay.
Yep. Other questions? Yes,
Hi.
over here.
Hi. Would there be any problem with taking a large block of public address space, substituting it for the private address space that you mentioned in your demo, and using that for your virtual subnets? I work for a university, and they've held on to their unfair share of address space. I'm sure they could make a lot of money if they
It requires
gave up some of
private.
it.
Virtual network does use private address space only.
Oh, only private address
Yeah,
space.
it's only private. For the local network address space, you can include public, but when you go to define the address space for the virtual network, it is expecting a private address, and it will only allow it in the UI, I believe.
Yes.
That answers a lot more questions for me, so I'll
Okay.
pass it on.
All right, thank you. Next question over here.
Yeah, can you put ACLs on the subnets to restrict traffic between VMs and different subnets?
Not on the subnets, no.
You can define ACLs on a given machine, similar to endpoints, that will say, I only allow traffic from these range of IP addresses. So if you had a web tier and a database tier, you could go to the servers in that database tier and say, I only allow inbound traffic from the addresses in this subnet range. So that is an Azure facility, and you can also do local host.
It's kind of like
ACLing.
security groups in Amazon?
It's not really security groups. It's through the portal. You say, these are the addresses I either allow or don't allow as inbound traffic to this particular VM.
And can you group those, or is it on an individual VM?
It's on an individual. The Azure facility is on an individual. Yeah. Yeah. Thanks. I'm sorry. Over here.
Thanks. One of the steps in your procedure is create the NLB solution of your preference.
Yep.
Is one of these options Microsoft NLB configured in your, let's say you have 2 terminal servers living in the cloud, can you add the NLB role to these servers and configure Microsoft NLB?
I believe that you can. It's not something I can necessarily speak to. That's certainly an option, but is that worth it, or is using the built-in Azure capability a better option for you? That's something you'll have to decide.
Thanks.
Okay, so that's a great point. So doing load balancing in Azure, and if that load balancing solution relies on multicast communication, then that won't necessarily work in the Azure environment. So thank you, Ed. That's a great point. Question over here.
You didn't really discuss the options of the load balancer, like sticky session, round robin. Like, what are the options of the load balancer that you have?
Okay, the Azure load balancer, to my knowledge, just does basically a random distribution of traffic based on the four, there's,
So if your application requires sticky sessions, it's not going to work.
your application requires, sorry, what?
Well, like in the F5, they call it sticky.
Okay,
I'm not an expert, but
yeah.
persistence, yes, and it's supposed to use some intelligence to decide who you're talking to, and only fail you over if
Right.
that host is no longer available, but your session restarts.
So Azure load balancing, to my knowledge, is a random distribution, but we also are probing the elements in the set that we're sending traffic to, and if one of those becomes unavailable, we stop forwarding the traffic to. But I don't believe that at this time we implement the sticky sessions feature. It really is just a random distribution at this time.
So to follow up with that, some companies have software load balancers. Could we then just deploy a VM and install their software load balancer to get
That's an
that
option
feature?
for you, yeah. Mhm.
Okay. Right. Okay. And
Yeah.
they're a more advanced load balancer from Azure, like a premium load balancer?
Not to my knowledge, not at this time.
Okay.
Yeah, it's really designed to solve a simple problem, which is I need simple load balancing, and I don't want to have to buy another or set up another load balancer on my intranet to do some simple load balancing to a bunch of servers that are running in the virtual network.
Right, but taking that a step further to
Yep.
building a DR site, you'd have to then, hey, if I require load balancing for this application, then I need to solve that, not with the Azure, but with my own.
I'm sorry, can you speak?
I can take it offline on the expert thing.
Okay,
That's fine.
okay. So I guess to answer your question, it's limited functionality at this time. If you require those sorts of features, then you'd have to step up and use a real load balancer. Okay. Yeah. No, not a real load balancer. Actually, Azure's is a virtual load balancer, so that sort of applies. Okay, next question.
Can you clarify the need to define these vast quantities of networks that you say is the local network that's not part of the virtual? Is that supposed to be representative of the on-premise network, if you would, or what's going on there?
The local network itself?
Yeah.
Yeah, it is. Yeah.
Mm-hmm.
Okay, so if I don't have all that network space, I don't need to be defining it. This is just for the purposes of routing back through to our VPN. Is that correct?
Right.
Okay.
So that's why you have that option of saying, well, I can just do the spaces that I'm using, and if there's not a lot of change in that, then you're probably fine. Okay. But I was thinking more of the enterprise where they're using bits of all three big private addresses spaces.
Gosh, I hope
and they may need to do some interesting things in order to make sure that they're excluding the right range when they define that local network address space.
Okay, thank you.
Yep. Okay. Question over here.
Hi. I was wondering, is there a way to, if you have multiple branch offices, can you connect them to a single virtual network on Azure, sort of like a multi-point or multi-site?
Mm-hmm.
Yes, there is. And
Okay.
we've got some documentation out there about that, and that was just announced, like, what, Monday morning?
Monday, yeah.
Okay, great, perfect.
Bright and shiny. So you'll see a lot of stuff on Thursday morning about that as well.
Okay.
Yeah.
Yeah, so go to that
It's a new
Thursday
feature.
session that was on the slide. Let me back up here real quick. Okay, so Thursday at 8:30 a.m. is a discussion of those features
Perfect.
that I've described very briefly, but there'll be a lot more information in this session.
Awesome. Thank you.
Okay, thank you. Any other questions? We are out of time, so thank you so much for attending. I appreciate your attention. Thank you so much. If you already know this stuff, and if you do, please yawn quietly during these sections as to not disturb your neighbor. But I'll try to get to some meat and potatoes here fairly quickly. Okay, what are we talking about? An affinity group is a way for you to tell Azure to place a set of services relatively near each other within a given data center. So optimized for performance. Call that an affinity group. A cloud service for our purposes is really just a container for virtual machines. Okay, it has a public presence, a public IP address. It also acts as a security boundary for allowing inbound traffic through endpoints, and you can define ACLs and so on. Okay. A storage account is just a way for Azure to account for VHDs and associated extra disks. Unfortunately, this is the only component in this list that does not have a logo. I understand that the storage account, people are aware of this, and they're frantically trying to create a logo. I think they're going to use a duck or something, so I don't know. We'll let you know how that works out. Virtual machine is just what it sounds like. It's a virtual machine in Azure. An availability set is a way for you to tell Azure, for all the servers in this particular tier of this application, this multi-tier application, I want you to place those servers on different racks in the data center so that if a given rack goes down, it doesn't bring down my entire tier. And then the last one is something called a virtual network, which we're very, very concerned with when we talk about hybrid networking with Azure. Okay, so what is this Azure Virtual Network? Well, other than it being a cute little logo with brackets and a couple of dots, it's essentially a container, this is hierarchy, to sort of give you an idea of the relationship of all these components. We have VMs that are hosted inside of a cloud service. Those can be part of an availability set. They can be on a subnet in a virtual network and be part of an affinity group. So, VMs in a cloud service, an availability set in a subnet on a virtual network, and an affinity group in the house that Jack built. So when you're configuring this, you keep this sort of structure in mind. Okay, now we're going to go through some other building blocks and describe the networking infrastructure and how everything works, so that when we get to the planning and design, you'll understand how things work with respect to these blocks here. Okay, address spaces. There's something called a shared address space. This is defined in RFC 6598, and cloud providers can use this space for the machines on their backbone. Okay, so if you create a virtual machine that's just in a cloud service, you might see this 100.64/10 address. Okay, it has a 100 in front of it. The virtual network address space is the address space that I assign to the virtual network. And it's very typically, in the case of cloud configurations, part of my on-premises address space, chosen very deliberately. And then the subnet address space is derived from the virtual network address space. Now here's a very interesting one called the local network address space. This is the address space that's either summarized as all of your reachable locations on your on-premises network, that allows you to structure virtual machines on subnets and with addressing that's very similar to what you would do with a data center. You can create a subnetted structure just like your data center and place virtual machines on those subnets and give it address space from your private address space that's an extension of your on-premises network. And we'll talk about the different types of subnets as we go along. Okay, so that's a virtual network. We have two different types of virtual networks. We have what we call the cloud-only virtual network, which has no connection back to your on-premises network. It exists completely in the cloud using reusable private address space. It has a subnetted structure, it can host VMs, fine. Well, we typically use this for internet-facing types of properties where we don't want to have a connection back to our on-premises network. And we can get to them, we can project ourselves onto them with what we call a point-to-site VPN connection. What we're really concerned with hybrid networking is the cross-premises virtual network. This is so named because it is connected back to your on-premises network using either a site-to-site VPN connection or a newer type of connection that uses actual live WAN links through a provider called an express route connection. You can also use point-to-site here. The point is that once this network is in place, it is really an extension of your on-premises network. And this is a hybrid configuration, so this is the type of configuration that we're most concerned with. Okay, now with all those definitions in mind, this is a little game I like to play called the infrastructure service. Okay, it is 5 o'clock and the bell tolls for thee. Good afternoon, everyone. Welcome to Designing Network Infrastructures for Hybrid Cloud. My name is Joe Davies. I'm a senior technical writer in the Azure Infrastructure Services writing team. I've been training, writing, and thinking about networking technologies, and more specifically Windows networking technologies for over 20 years. Taking time out for meals, sleep, and to spend time with those people that live in my house, especially the ones that call me sweetie. What's the other term they call me? Oh yeah, daddy. I've written literally thousands of pages. Written literally, yeah, it's a little writer's joke. Thousands of pages of documentation on Windows networking technologies. I was the cable guy. I wrote the cable guy column for a number of years. I've written 9 Microsoft Press books, including the most recent Understanding IPv6 version, 3rd edition, and scads of TechNet and MSDN content, some of which was actually relevant. So, I'm here to take you on a little journey. Hang on a second. They skipped my agenda slide. Okay, so I'm going to do the agenda slide completely verbally. All right, I'm here to tell you a story. And that story is, how do you think about and plan to properly implement an Azure Virtual Network for a hybrid networking configuration? That story is going to be told in 3 parts according to classic 3-act story structure. Act 1, I call this the what and the why, gives you the building blocks, the terminology to understand the Azure networking environment and sort of relate it back to what you already know, which is you already understand the networking environment that exists in your data center. Here's how it works in Azure. Act 2 is the how, the planning and design. I'm going to take you through a number of issues of planning for Azure networking and talk about things like addressing, routing, name resolution, and how those work in Azure and how you need to plan for them. At the end, we're going to recap in a form that gives you step-by-step procedures for doing this on your own and a list of things that you need to determine prior to plunging into creating a virtual network with the Azure Management Portal. Act 3 is called putting it into practice, and that's where we will actually take this process and this checklist and take you through the paces of setting up a fairly simple topology, a SharePoint 3-tier farm. And we're going to go through that step-by-step process. We're going to go through that checklist. We're going to actually try to configure it end-to-end. We're not going to demo all of this because it takes far too long, but we're going to show you that step-by-step process all the way through the end-to-end configuration, to give you an example. Okay? All right, so Act 1, the setup. The what and the why building blocks. Okay, so I'm going to take you through a bunch of Azure concepts and define them, use them in a sentence. I apologize in advance.